Okay, guys, picking back up in lesson 3.6. This is a question we left off with yesterday, where we're finding complex roots. Remember, we started with PRRs. We then used synthetic division to confirm which ones work. And then after synthetic division, we looked at whatever we had left, and in this case, we used quadratic formula to solve. Okay, but you're solving whatever you have left to find the rest of your roots. You're either going to be asked in homework for a factored form like this, or roots, or as in zeros, okay, or solutions. So I don't think they would ask you to put both of these forms. They're going to ask for one form or the other, okay? So we're ready to try B. So x cubed minus 2x squared plus 5x minus 10 equals 0. Where do we want to start? What did you say?
Your constant.
Yeah. We're going to start with our PRRs. And so as we start with these PRRs, factors of the constant. And so what is my constant here? Factors of negative 10. Divided by factors of what? The lead coefficient, which in this case is an invisible 1. Okay, so constant. And I'm not saying you need to be labeling these, but I keep labeling them as a reminder. Lead constant. Okay, factors of negative 10. What do you got for me?
1 and 10.
1 and 10?
2 and 5.
2 and 5. That's it, and all of those we're going to say plus or minus. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. Factors of 1?
1.
Plus or minus 1. It's 1 times 1. Now, that makes this list of PRRs pretty easy because it's everything over 1, isn't it? There's not a whole lot of mixing and matching. So that means my official list of PRRs, in all honesty, if I'm not grading, I would probably just leave this one like this. Because can I see all of my options?
Yep.
I can. I'm going to be official and list them since we're still learning, though. Plus or minus 1, 2, 5, and 10. Okay, so those are my PRRs. And as I think about when you have to pick PRRs in homework, multiple choice, I think they do it like 1, negative 1, 2, negative 2. Like they don't write the plus or minus. You're nodding, is that right, Nora? Like they list them in positive, negative, so on and so forth. So, okay. What do we do once we have our list of PRRs? We're going to go to Desmos. And we're going to check out and see what kind of help Desmos can give us, right? So if you haven't practiced, I would practice. Okay, you're going to check your PRRs on Desmos. Okay, so go to Desmos. And tell me what we're going to try. So plus or minus 1, 2, 5, and 10. Those are the options we're looking for. No fractions, no decimals. We're looking for those pieces there. Okay. When you type it in, as I said, you don't need the equal 0. I don't know if putting the equal 0 in hurts you or not. It does mess it up if you put the equal 0 in. Okay, that's true. Okay, that's what I couldn't remember. So x cubed minus 2x squared plus 5x minus 10. Are we getting it typed in? And my thing is, I know specifically in this class, I didn't have Desmos up and running appropriately yesterday, so I want to make sure that we know what we're doing there. I would do something like this where I would provide a graph or something. Okay. I don't have that quite worked out, you know. I don't remember what kind of problems I did with in relation to this last year. I don't have this year's test ready to go yet, so I don't know, That, yeah, you would not be using Desmos or a graphing tool on the test. So you would have to, I would give you whatever information you need there.
If you want to, you can copy the test. Sooner or later.
Thank you for volunteering, Patrick. Okay, what do we come up with here? Your graph looks like my graph. It crosses at 2, yes? Okay. This is the technique I want you to use in homework, though, is just go to Desmos and, and we talked yesterday. I don't think you were here yesterday, but the other option is we can go through, try all of these possibilities with synthetic division. We don't want to try all those possibilities with synthetic division, so we're narrowing down our starting place. Okay. So, x equals 2, only 1. So what is step 3? Step 3 says we're going to put 2 into our synthetic division and try it, yes? What goes next to the 2 in synthetic division? 1. -2. 5. And -10. Okay? So still reviewing and using those synthetic division skills that keep coming back at us. Drop the 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 is 0. 5 plus 0 is 5. 2 times 5 is 10. -10 plus 10? 0. Okay. Of course, the 0 worked. We always want to check and make sure the 0 works. Now, with that in mind, some information here. Two worked. What does that represent as a factor? Patrick?
X minus 2.
Okay, so right now, we know we have x minus 2. Then, I don't have any other zeros to try, do we? On the one we did yesterday, we had 2 zeros, so then we tried the other 0. This one we only have 1 0. So now we're looking at, what does this 105 represent? Okay, so x squared plus 0x that we don't need, and plus 5. So as of right now, my other factor is x squared plus 5. Does that factor farther? It doesn't. And so in all honesty, what you just found right there is your factored form. Well, we still have to find our other solutions, but this is not, because x squared plus 5 doesn't factor into 2 real factors, we're going to find imaginary solutions next. This right here would be your factored form. And I know yesterday I went back and did it at the end, but I'm realizing that right there is your factored form. Okay? Now, step 4 is when they actually ask us to find the zeros, which I think they use the word zeros. Okay? I use the word the roots. Same idea. So what are we going to do to find our actual solutions? We're going to have to set each factor equal to 0. We already know the x minus 2, right? But the one we have to work with is the x squared plus 5. Okay? So, we already know x minus 2, so we know we're going to have the solution of x equals 2. How do you want to solve x squared plus 5 equals 0? Huh? No, I can actually get away without the really long equation. Okay, I'm not going to square root yet. I'm going to subtract the 5 over first, And so I think what McKiley was getting at was quadratic formula. Okay, we get to avoid quadratic formula because there's no x term here. Okay, so subtract the 5 over. X squared equals -5. And now we're going to square root. What is the square root of -5? Okay, square root of the -1 is going to become an I. Square root of 5, stay square root of 5. And I think I heard at least one person say it. Plus or minus, because we took the square root in an equation format. Okay. Those right there are your roots, is what I called them on this paper. I want to say the homework might use the word zeros. Okay. But those are your roots or zeros, whatever it's asking you for. Huh? Did it use roots? Okay. For some reason I had a note here that I thought I saw zeros, but maybe I just wrote that as my note and it didn't use roots. It's, who knows? Okay. Okay, guys. You've got the steps in front of you, yes? When you go to do the homework, refer to these steps. I've tried to break it down into steps so you can kind of see a 1, 2, 3, 4, like process to follow. Use these steps, okay? I don't have them written out, but my hope is that you can follow your notes. The steps will help. Okay? Okay. Our other topic in this lesson has to do with writing out equations. Okay? Writing out equations based on the roots. Now, before we go into that, we need to talk about something called the conjugate root theorem. If a polynomial has either irrational or imaginary roots, okay, then those roots always occur in pairs. I've kind of already mentioned that a little bit. Okay, we haven't done anything with it, but I haven't mentioned it. So when we talk about imaginary roots, those are the ones with i's, right? They're always going to occur in a pair, a plus or minus pair. Irrational roots, which irrational roots are the ones that have like square root of 5 in it, square root of 21, square roots that we don't know. Okay, those also occur in pairs. And here's the deal. Okay, there are conjugate pairs, meaning basically the middle sign is different. If a plus the square root of b is a root, then we automatically know that a minus the square root of b is a root. Same thing in terms of imaginaries. If a, that's a little bit of a typo there, isn't it? That is supposed to say, if a plus bi is a root, then a minus bi is a root. I must not have caught that last year to fix it. Not sure how I didn't catch that, but if a plus bi is a root, then a minus bi is a root. Okay? So they always occur in pairs. Now, here's the deal. Are they going to tell you those pairs are there? No. They try and be tricky like that. They say, okay, a plus bi is a root. You have to automatically process and know, oh, they said a plus bi, so now I got to use a minus bi as well. Okay? Same thing with the square roots. Okay, so moving forward with that concept in mind, we're going to write some equations. This first one asks us to write a quadratic equation in standard form. So in standard form means it has to be multiplied out with rational coefficients that has a root of 5 plus 4i. Okay. Now, they're telling us to write a quadratic equation. What power is a quadratic equation? Quadratic is x to the, not fourth, second, right? So it's x to the second. If it is x to the second, that means there's supposed to be two solutions. What'd they give us?
4.
They just gave us 5 plus 4i. What do we know? If 5 plus 4i is a root, then 5 minus 4i is a root. Okay? These are the conjugates. Conjugates, you keep the same pieces, you just change the middle sign. So if 5 plus 4i is a root, so is 5 minus 4i. Now, we have to write this as an equation. So, as I write it as an equation, first of all, I'm going to start with f of x. That's probably what you're going to see in homework. Now, how do we write this as a factor? So normally, okay, let's just start if the root is 5. How do you put that as a factor? You do x minus 5, right? Now, our root isn't just a single number, though, is it? Our first root is 5 plus 4i. So this is going to be x minus, and I'm going to use another set of parentheses, because it's going to be x minus the root of 5 plus 4i. Okay? The other factor we have to set up, x minus, what's my other root? 5 minus 4i. So notice I basically set up 2 parentheses. I know they both have parentheses within them at this point. But we have x minus the 5 plus 4i, and we have x minus the 5 minus 4i. Okay. If we clean those up a little bit, so we don't have parentheses within parentheses, what is x minus the quantity 5 plus 4i? If I remove those inner parentheses, what am I writing? X minus 5 and minus 4i. Because what is this minus sign out front doing? This minus sign out front side of the parentheses has to distribute in. So it's changing not just the sign of the 5, but also the sign of the 4i. Same thing on this one. X minus 5 and x, well, minus 5 and, minus negative 4i, which is plus 4i. Okay? As you get used to it, that process will get easier. It said standard form, so do I get to leave my answer like this? Unfortunately, no. Okay? We have to multiply this out. Standard form, it's all multiplied out, and we have our terms ordered from highest to lowest, greatest to least. So, distribute, right? It's a big bad FOIL. It's just instead of doing 2 by 2, it's 3 by 3. You ready to FOIL with me?
No.
No? Okay. Okay, so I'm going to start by taking this x right here, and I'm going to multiply it by everything in the other parenthesis. Make sense? So I'm going to say x times x is x squared. X times minus 5. Minus 5x. X times 4i. Plus 4ix. Okay? Now I'm going to repeat that process, and now I'm going to use this negative 5. And I'm going to distribute it by everything in that middle, in that other parenthesis. So negative 5 times x, minus 5x. Minus 5 times minus 5, plus 25. Minus 5 times 4i, minus 20i. And then distribute the negative 4i to everything. Negative 4i times x, minus 4ix, minus 4i times minus 5, about plus 20i. And minus 4i times plus 4i, minus 16i squared. Folks, that line right there is where your mistakes are going to happen, isn't it? Okay, you just have to be very careful. Okay, we're going to make mistakes. Be very careful. Have a lot of patience with yourself. Okay, let's do some cleanup. What kind of cleanup do you see? Okay. If this problem is done correctly, your IX terms and your I terms should always cancel. Okay? If they don't cancel, there's a mistake somewhere. Okay? So plus 4IX cancels with minus 4IX. Minus 20I cancels with plus 20I. All I's are gone except for, yeah, the I squared term. But what do we know about I squared?
-1.
Yeah. Remember, negative 16I squared is negative 16 times negative 1, which is plus 16. So this term really just becomes plus 16. So our I's are really all gone, aren't they? As it should be. Okay. Final cleanup. Okay. We have an x squared term. Only one x squared term. We have some x's, yes? Minus 5x and minus 5x is minus 10x. And we have a plus 25 and what became a plus 16. Plus 25 and plus 16 is plus 41. Okay, guys. There's our quadratic equation in standard form. It's all multiplied out. Goes from highest power to lowest power. Notice it says with rational coefficients. So there's no i's left. There's no square roots left. Okay? That's kind of what the rest of this page is. This, of course, was beginning level. So the pieces get a little bit bigger. But this is the idea of what we're looking at. We're looking for the conjugates, and then we're going to be multiplying them out. Okay? Ready to try B? Okay. What is a polynomial function Q of degree 4 with rational coefficients such that 2 minus the square root of 3 and 5i are roots? So this particular problem tells us it's going to be degree 4. That's kind of a hint. Okay, the Q there is just what they're naming it. They're just saying it's going to be function Q. It says degree 4, so how many zeros should I expect, or how many roots should I expect? 4. How many did they give me? 2. What do you know?
2 plus square root of 3 is 4.
Okay. If they give me 2 minus the square root of 3, that's an irrational root. I have to use its conjugate, so then also 2 plus the square root of 3. What else? Yeah. If they give me positive 5i, think of that like 0 plus 5i. What would be the conjugate of 0 plus 5i? 0 minus 5i. So negative 5i. Okay. Good news, bad news. We've got all the pieces. This one's going to take a little bit more work, isn't it? Okay. And so let's get this set up. I guess instead of f of x, it does say q. So I'm going to call this one q of x. Why not? Okay. I'm going to write out all my pieces like I did last time, so you make sure we get started correctly. So it's always going to be x minus the root. So I'm going to say x minus, I'm going to say the quantity, 2 minus square root of 3. If you can skip this step and go straight to what it is without those inside parentheses, more power to you. Just don't make mistakes, okay? So that's x minus the 2 minus square root of 3. The next one is going to be x minus, this time I'm doing 2 plus the square root of 3. And those 2 minus and 2 plus square roots of 3 are in parentheses. Now I'm going to do x minus 5i. And then I'm going to do x minus negative 5i. But what do you guys know about x minus negative 5i? That's just going to be x plus 5i. Can you go straight to x plus 5i? Most definitely. Okay. Now, do notice as I set this up, I did this without mentioning it. I did put the conjugates next to each other, right? It is incredibly important when you go to do your first multiplication step that you multiply a conjugate with its conjugate. Don't try and multiply the 2 minus square root of 3 times the 5i in your first step. You will have a lot more terms than what is necessary. Okay? If we multiply the conjugates, our i's will cancel out in the beginning. Okay? So, I'm going to go ahead and clean up these two where I have inside parentheses. X, you got this first one, minus 2 and plus square root of 3. Change both signs. Next one is x minus 2 minus square root of 3. We still have x minus 5i and what we already called x plus 5i. Okay. Got your multiplication brains on? Okay. What I'm mentioning here, we're going to multiply these two. We're going to multiply those two. We're going to get an answer. We're going to get an answer. And then guess what? Multiply them again. Okay? Let's do it. Okay. I'm always going to use the same idea. So I'm going to take this x here, and I'm going to distribute it by all three things. So I am going to start a parenthesis here. X times x is x squared. I know, do you want me to draw the lines, or is that too much? X times x. X times minus 2. Minus 2x. X times minus square root of 3. Yeah, and I just wrote it the other way around. Either way, yeah, I should have. I agree more with what Mikhaili said than what I wrote, so minus x square root of 3. Can you write it the other way? Yes, just make sure your x doesn't get under the radical, okay? Okay, so there we distribute the x. Now I'm going to distribute the negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 2, plus 4. Negative 2 times negative square root of 3. Negative times negative makes it positive, and then you can just write it as 2 square root of 3. And then we still have to distribute the square root of 3, yes? Square root of 3 times x. Plus x square root of 3. Square root of 3 times negative 2. Minus 2 square root of 3. And then square root of 3 times negative square root of 3. What is square root of 3 times square root of 3?
Square root of 3 squared.
Okay, 3 times 3 is 9. Can we say square root of 9?
Yeah.
Yeah. What is the square root of 9 going to be eventually? 3. Could you go ahead and say 3? Whichever one makes you happy. The outside is negative. Okay, it's a positive times negative, which makes it a negative term, but the negative is not inside the radical.
It should be minus.
Right, so that is just going to be minus 3. Okay, that's my first step, folks. We're going to have to go back and clean that up here in a moment. But I don't want to forget, I'm going to do my other multiplication now, too. Now, my other multiplication is technically just FOIL, isn't it? And so, x times x, x squared. X times 5i, 5ix. Insides, negative 5i times x. Why did I put a parenthesis there? Minus 5ix. Minus 5i times plus 5i. minus 25i squared. Okay? Again, if done correctly, some good magic happens here. Okay? In the first one, was there some canceling?
X squared root of 3, 2 square root of 3.
Okay. Minus x square root of 3 plus x square root of 3. Patrick, back of the room. Minus x square root of 3 plus x square root of 3 will cancel. Plus 2 square root of 3 minus 2 square root of 3 will cancel. Anything involving a square root of 3 should cancel, yes? And then we already talked about it. If you haven't changed it yet, minus the square root of 9 is minus 3, yes? Okay. Now, if I do a little bit of canceling in this one, 5x minus 5x will, 5ix minus 5ix will cancel. What's minus 25i squared? Plus 25, yes? So notice, all square roots are gone in the first one, all i's are gone in the second one. Okay. Let's clean up that first one. I have 1x squared term.
Minus 4x.
Minus 2x and minus 2x is minus 4x.
Oh.
Plus 4 minus 3 does make it plus 1. Okay? The other one. We have x squared. Middle's canceled out. Minus 25i squared became plus 25. Square roots are gone, i's are gone. Now we need to multiply one more time. So start multiplying one more time. With this in mind, I don't care which way you do this. I tend to take these two and multiply them into the other three. That's me personally. Could you take each of these first three and multiply them into the other two? It all works out in the end. So I tend to say, okay, x squared times each of the first three. So if I do that, x squared times x squared is x to the fourth. X squared times minus 4x minus 4x cubed. X squared times 1 is plus x squared. And then if I'm following that trend, I'm going to distribute my 25. 25 times x squared plus 25x squared. 25 times negative 4x minus 100x. And 1 times 25, 25. Okay. Final step. X squared's all that combine? Guess they are, aren't they? Okay, so x to the fourth minus 4x cubed plus 26x squared minus 100x plus 25. Or I can get it set up and the multiplication is still the same.
Not enough time. We won't remember anything. We can't retain any information that's listed about.
Patrick's got CTE, so we can't.
Yeah.
Can't get CTE.
Okay, let's talk about C.
Oh.
Just like overview it.
Form a polynomial f of x with real coefficients having the given degrees and given zeros. Okay, degree 4. You guys know what that means. My highest power is going to be x to the fourth, right? all they tell me now are zeros of 3 minus 5i and negative 1 multiplicity 2.
What's that?
Okay, so negative 1 multiplicity of 2 means that there's going to be the 0 of negative 1 is going to occur how many times? Twice. So that means there's negative 1 and then there's also negative 1. If there's 3 minus 5i, what do you know?
3 plus 1.
There's 3 plus 5i. And then you're going to need 2 of the minus negative ones that become plus ones. Okay. So let's get the setup going. X minus the 3 minus 5i. So, depending on where you're at personally, I wrote as x minus in parentheses 3 minus 5i. If we have 3 minus 5i, we have the conjugate 3 plus 5i. So x minus parentheses 3 plus 5i. Okay. Negative 1. It's x minus negative 1, which you guys really know to be x plus 1. Multiplicity 2. Remember multiplicity, technically multiplicity says there's going to be a power of 2. But how do we really write that out? If we're going to have to multiply this out, this just means we're going to have another parenthesis that is x minus negative 1, or in other words, x plus 1. Okay? In this next step, if it's x minus the quantity 3 minus 5i, that's what? X minus 3 and plus 5i. If it's x minus the quantity 3 plus 5i, it's x minus 3 minus 5i. And then we have x plus 1 times x plus 1. You guys know we'd be following the same process, yes? Foil those two. Foil those two.
We don't have to have plus ones for the negative ones, we don't have to have plus ones like I have to have the 3 plus 5i, you don't have to have a plus 1.
No. Okay, so good question. Do we have to have a conjugate for negative 1? I just realized what you're asking. Okay, no. The only one we're using conjugates on is when there's i's or square roots. If it is just a plain old everyday number, no conjugate. Make sense? Okay. I'm going to put up an answer up here that you can check against. The process is the same. You'll multiply the first two and the second two. Okay? The process stays the same there. Okay. Three, 6 homework, folks. There's a lot to this homework, yes? These problems are not short problems. These problems are going to take some work. These problems are probably going to take some help. Okay? Please take time to start the homework and look at it. Okay? There's I don't know, this could be something, and this is why I'm using Friday as a work day.
Friday.
Okay, so I have 3-6 due as Friday. However, I want you want you looking at it so we can see where we're at in terms of questions. Okay, my tentative plan is to start 3-7 notes tomorrow. I just won't have 3-6 due until Friday. Okay, so look, see where you're at, and we'll go from there.